Today's lesson is about self-preservation. Today's lecture is about self-preservation. Do you guys want to be preserved or do you want to die? So as I was talking to Adam and Riley before class, is that so many people in running projects get trampled underfoot, Led Zeppelin song, because they don't use this technique that I'm going to show you today. This is really the meat and potatoes for project management to get an effective schedule put together. And I would say that probably 90% of people that have been assigned to work on projects, they don't use this because they either don't know it exists or they think it's too difficult. So this is very, very important that you understand how to do this, not just to be able to do well on an exam, but to be able to use it in the real world. So here's our objectives. The first thing we're going to do is we're going to make sure you understand how the connection between the work breakdown structure and the project network. Then we're going to actually do a network. We're going to calculate these different times. We're going to identify and see how we can use the critical path. Then we're going to talk about slack, and then we're going to talk about lags. And I'm going to add one that's not in the book and not in the slides. It's called a lead. So you have lags and you have leads. So I'm going to give you that, and that's not in the book. So make sure that you pay careful attention. So that's our agenda for today. So what is a network? It's a graphical flow chart. So if you guys like making flow charts for any courses that you've had, maybe computer programming or anything where you have to make diagrams, you're going to love this because that's the first thing that you need to do. And the diagram that you create is going to be logically developed. It's going to show how the different tasks or activities relate to each other. You're going to put times to start and finish, and you're going to identify the longest path through the network. That's the critical path. So a future question on exam could be, which of the following items are not part of the critical path? And if you know the critical path is the longest path, you're going to be in good shape. This is the foundation to do these things, including getting money. It helps people communicate because everybody's looking at the same thing. Now, this is important because if we're making a flying car, it could be that there's 721 tasks to make a flying car, but only 82 of them require careful attention. So the other 700 plus tasks do not require that much attention, and that should be good news for you. Because if you're a project manager and you've got a project that has 782 tasks, that's going to take up a lot of time. But if you only have to look at 82 and the other 700 are less critical, then you're going to be happy. Okay? And then there's some activities that we can use to compress the project duration, compress it. All right, so let's get into it. So the first thing we're going to do is we're going to see the relationship between the work breakdown structure and the network diagram. So as you recall from the exam, one of the questions was, what is the lowest item in a work breakdown structure? And the answer was a work package. So here we have a bunch of work packages that are related to these different areas, organizational units, and we have 7 work packages here. Yeah, 7. So we have 2 for design, 2 for production, 1 for test, 2 for software. So what we've done is we've given them codes so that the people in accounting can know how they're going to charge time and materials to those tasks in the financial statements. You with me on that? Hopefully that rings true. And then what we're going to do is we have these 7 that are just listed. We're going to put them in sequential order here. Okay? So the first thing that's going to happen is we have the specifications and the documentation that go together. You can't do anything if you don't have these. Then we're going to take a prototype 1 and we're going to take software preliminary, and those are going to happen concurrently at the same time. Now, if you only have one person, they may work on this for 4 hours and then do this one for 4 hours, so they get done on the same day. But it could be that you have 2 different people, so they work on these at the same time. It's not necessary to do the software before you do the prototype because they're independent. You see that? One is a physical thing and the other one is an electronic thing. And they can be developed at the same time. Got that? So if you have a laptop computer and it's being built at a factory, somebody is developing software at the same time the computer is being built. And the computer is flexible enough, it can run all kinds of software, correct? So you're not worried about that. But then, before you can do the final prototype, you have to have the software and the initial prototype, both together. Then, bless you, you're going to do the final software, because once you get the final prototype, you may have to go in and tweak the software, because it may not be working the way you want. But once you do the final software, then you're going to test it, test the system. Everybody with me on this? This is a very, very simple illustration of something that is much more complicated. So if you understand this, you're going to understand the bigger one if and when you get there. Now, if you don't like these codes, you can use words. See that? This and this are the same thing, just defined 2 different ways. Everybody with me so far? Okay? So imagine you had 7 Post-it notes here, 1 for each one. You're going to take the Post-it notes and you're going to put them on the board here in this kind of order with your team. And if you don't like the initial order, what are you going to do? You're going to change the Post-it notes, aren't you? And it can be very easy and very fast. So that's how you put together your network diagram. Now, if you don't have Post-it notes and you don't have a board, you can just do it in Excel, or you can do it in Microsoft Project, or you can do it on paper with a pencil. Okay? Like I did here. Okay? Same thing. Everybody with me on this? This is a very, very important slide. So I highly recommend that you study this and know this very well. You'll be in good shape. All right, so now some verbiage, some terminology for the network. So the activity is the same as a task. Task activity. We just had 7 tasks. We had 7 activities. Parallel activities. We had 2 things happening at the same time, didn't we? The prototype and the software, preliminary software. So we know what that is. A burst. An activity that has more than one activity immediately following it. So look at this. This is a burst, right? 1 burst to 2. You with me on that? Okay? So what happens is you're driving down to Destin, and invariably you're going to get some road construction, aren't you? Where you're driving like 80 miles an hour, then it's taken down to 1 lane. Don't you hate that? And you have no idea how long that's going to last. But you can look at your GPS, you see red, like, okay. But eventually, what's going to happen to that 1 lane? It's going to turn into what? 2 lanes. That's a burst, right? You follow me? But then you're driving along And oh my goodness, the 2 lanes, what happens? Down to 1 lane again. You had to merge. So burst is when it goes to 2, and merge is when 2 go to 1. You got it? You'll never ever forget it now, will you? You'll know it forever. That's what's going on. A path, sequence of connected dependent activities. So in this one we have 1 path and we have 2 paths, don't we? We have 1 path that's ABDFK, another path is ACDFK. We have 2 paths. You can have many, many, many paths, as you're going to see. Everybody got that? So this terminology should not be that difficult. And the critical path is the one that's going to take the longest. So let's just do it for fun. Let's say that each one of these is 1 day, except this is 2 days. So how long is path ABDFK? How many days? 5 days. What about this one? This is 2 days. What's this path? Shout it out. 6. So which one is the critical path? This one. It's the longest one. You understand? That's it. That's all it is. Here's what's cool. If this one takes you 2 days, what's this path going to be then? 6. It's going to be the same. If this takes, it was planned to do 1 day, and it's going to take you 2 days, is that going to be a problem? No, because this one's still 6. So your project is still going to be 6 days. But if this takes 3 days, this is no longer the critical path. You have a new critical path, which is this one, which is now 7 days. Everybody with me on that? Okay? Okay, I hope so. All right, so this is called the activity on node process. Activity on node. So this is a node. I got a node right here on my jawline. Has anybody ever noticed it? It's right here. Take a look. You don't see it. Why not, JJ? I'm symmetrical, aren't I? When you get to be 69 years old, you get jowls. Your face starts to melt. So the left side and the right side look pretty similar. But some people get this here. They get it in their forehead. Not good. I'm fortunate because it's kind of hidden. My doctor says we're not going to cut that out because you got all these nerves going through here. If I cut this, your whole face may be like that. That would not be good. So a node is a structure. The node here is a box. You got it? And the activity name is inside the box. Activity on node. You got it? It's on the node. It's on the box. Okay. Now, here we go. Here's the burst that you just saw. A burst to 2. I don't need to belabor this anymore, do I? And here's the merge. Okay, the 2 lanes. Oh my goodness, it's down to 1 lane. It's even worse if there's 4 lanes that go down to 1. Does that ever happen? Sure. It's awful when it's at night. You got all those bright lights. Your eyes are hurting, especially if there's those flashing lights. I don't know why you have to put flashing lights. It's like a spaceship. If you go back to the 1950s, the police cars, they had one little red light. That's all you needed. Now it's like we're a spaceship coming after you. And if you're driving and you look behind you and you see those spaceship lights, you get nervous, right? Like, oh no, how fast was I going? Where's my registration? I better throw this out the window. I better swallow this. No, you wouldn't do that. Everybody with me on the merge? Okay, good. Okay, so we're going to do an example together now. This is pretty much the rest of the class. So this is a real, like, clean lecture, just sticking to the topic. Okay, so we're going to have an automated warehouse where there's all robots, no people. The thing is like 120 degrees, unfit for human occupancy. So we have 2, 4, 6, we have 8 activities now, don't we? Instead of 7, we have 8. And here's their names. What we did is we put what are the predecessors. So you could define requirements anytime you want. You could do it now. Okay? Now, after that, to assign the team and design the hardware, you have to have your requirements. If you don't have requirements, you don't know who's going to be on the team, and you don't know what the hardware is going to be like. So you got to do this before you can do these. Then you're going to code your software based on these two things. Then you're going to build and test hardware, develop patent request. That's based on the design the hardware, right? And then you're going to test the software, which is based on coding the software. Then you're going to integrate these three things. Now, I want to take a moment and clarify something for you that gets people hung up sometimes. The beauty of the network diagram is there's something called a decoupling effect. Decoupling effect. Decoupling. Okay? Now, if we go back and look at this here, if we had 10,000 tasks, this thing is going to go from left to right all the way, right, around the room. See it going? It's going around the room. I used to have a deaf dog that I used to torment her with my laser pointer. For some reason, the light just made her go crazy. She couldn't hear, so I think her vision was, see it going? So this is like a scroll. Imagine this being a scroll, okay? A scroll. Now, when you're out on task number 300, that means that task 1 through 299 are done, right? Do you care about them if they're done? If you're working on task 300, Dylan, you should be concerned about task 299, right? Because that came before. If it's not done, what does that mean for 300?
It's not going to be done, right?
Or you can't start. You can't start it if it's not done because it's dependent, right? And 301 is dependent on you being done. So imagine your scroll, it's a TV screen. You got 3 tasks on your TV. You got thousands more to do that are not on the TV, and you got 298 that are not there because they're already done. You understand? Once you decouple, you don't have to go back because someone could say, well, for me to do E, I got to complete A, B, and C, right? That's true. But if you're doing E, you're only dependent upon C, and for C to be done, it has to be complete, and it was dependent upon A. You follow that? C's already consumed A's work. It's already there. It's there. So you just need to be concerned about what's happening right before that hasn't been done yet. You guys understand that? Because when you do this in Microsoft Project, which is coming up soon, you're going to have to put together a list like this, and it's going to be twice as long. And that's why you're doing it as a team. Because last semester, a lot of people struggled individually. I don't want you to struggle. If you do it as a team, hopefully you're going to be able to understand all of the elements and do a great job. Okay? So I just wanted to give you a heads up on that for right now. Okay, so now, oh, this is so awesome. Don't you love the PowerPoint slides on this? Because look, other classes, this would be gone, but what they did is they reproduced it right here for you. So now you can see and compare here. Isn't that awesome? Yeah. So look, here's A, it starts now. And then B and C, they're dependent upon A, aren't they? And then D is dependent upon B. And E and F, right here, they're dependent upon, E and F are dependent upon C, right? Here they are. And then you got G dependent on D, and then H. Look at H. G, E, and F. You got to merge here, don't you? You got 3 lanes going down to what? 1 lane. You got it? Here you got a burst. You got A bursting to B and C. Okay, everybody with me? We're just taking what you saw earlier and we're making it a little bit more complicated. But this should not cause anybody any trouble at all. Anybody have any questions so far? No? Okay, good. Let's move on. Okay, so we just had Super Bowl. Everybody knows what a forward pass is, right? You know, the forward pass in football, it didn't always exist because people used to not throw the ball like that at all. But now we have a backward pass. And you know, usually you got the quarterback and he's going to do a lateral back, right? You've seen people do that? That quarterback could turn around and throw the ball backward like that. That's legal, I think. So that's the backward pass. So the forward pass is telling us 3 things. Important to know. First one, how soon can an activity start? It's called the early start. Does that make sense? Yeah. How soon can it start? And how soon can it finish? Early finish. And how soon can the project finish? The expected time. Okay? So it's going to tell you the project finish time. Okay? That's the forward pass. The backward is really you're working in reverse. So we should probably call it a reverse pass. You're in reverse now. How late can it start? How late can it finish? Which items are on the critical path and which activities can be delayed? So let's talk about this. How late can an activity start? Let's go back. Okay, this is going to be day 1. Takes 1 day. Okay, good. This takes 2 days. This takes 1 day. Okay? So this one, as soon as you, let's say this is Monday, what day does this have to start? It's not a trick question. This started on Monday, it takes 1 day. When can this start? Tuesday, yeah. If this takes 2 days, when's it going to finish?
Thursday.
It's going to start on Tuesday morning. When's it going to be done? Wednesday night, yeah. Okay, good. Now this one takes 1 day. Okay, this starts and finishes on Monday. This starts on Tuesday, finishes on Wednesday. When can this start? Thursday. You with me? Now, here's what I'm getting at. This takes 1 day. I can start this on Tuesday. If I start this on Tuesday, nothing's happening on Wednesday, right? Because it only took 1 day. But if I decide to start this on Wednesday and not work on Tuesday, it only takes 1 day. Do I have a problem? No, because it needs to be done by Thursday morning, right? Along with this one. You understand? So the latest start on this one is Wednesday. The earliest start is Tuesday. Everybody got that? That's what I'm talking about here. That's what you're going to see in a minute. Okay, so here we are. So we have our diagram. We talked about this. So now we need to assign some time correct? How long is it going to take? These are work days. So this is Monday through Friday. So this one's going to take 10 work days. So how many work weeks would that be? 2, yeah. Okay. 1 work week, 5 work weeks. You guys with me? 4 work weeks, 10 work weeks, 3 work weeks, 7 work weeks, 3 work weeks. Everybody with me on that? Okay. You got to have these, otherwise you can't move forward. Now, when you do your Microsoft project assignment number 3, when you look at the narrative, there's a few paragraphs. You're going to have to translate those words into these predecessors and these times. You got it? Because think about this. If you went to a company and they wanted you to make a project, they're not going to give you this. They're not. They're going to say, well, go talk to DeAndre, go talk to Jackson 1, Jackson 2, and they're going to tell you what you need. So you interview them. Guess who's going to put this together? Guess who, Adam?
I wish I could.
You're going to put it together. You're going to do it.
That's right.
If you can't do this, is the project going to get done? No. So I'm wanting you to do that exercise to give you an opportunity to translate user requirements into this, because this is what you need. That's why I told you in school, a lot of instructors are going to give you this on a silver platter, right? And you can do it and get 100%. You go to a company and they'll say, oh, we see that you took Management 4003 from Swain. We know he's awesome. So go and talk to DeAndre, Jackson, and Jackson and put together a project plan and come and show it to me. Otherwise, I'm going to fire you right now. They may not tell you that, but that's between the lines. So if you can't do this, you're on the street. You need to know how to do this. You need to know to translate words into this, but then when you have this, you need to know what to do with it. I'm showing you what to do with it today, but you're going to have to translate it later on when you get to that assignment. And there's 4 of you on it, so you should be able to do it. And you know what? Your version may be different than mine, and that's fine, because your understanding was different, but you're able to support it with evidence. Okay? All right. Okay, look at this. How many people like doing this kind of stuff? Anybody? I think it's fun. So now you got your format here to do your network diagram. Okay? So you don't have to create this from scratch. I'm going to give you this. It's in the book. It's awesome, because look down here. This is what you want. This is a legend. So you have 7 boxes here, actually 8. You write the description, you put an ID number, its letter, you put its duration, how long it's going to take, then you compute early start, early finish, latest start, latest finish, and slack. Okay? That's what you're going to do. So that's what we're going to do right now for the next few minutes. So here we go. We got our diagram. It's exactly like what you just saw here, but now you're having those 8 sections in each one of these boxes instead of just 2. Here they are, 8. Okay? 8. So, when you first get this, it's going to be blank. You got a blank sheet. So if we did this together, this is what you're going to have for the starters. So you're going to put the letters, you're going to put the name of the task, and you're going to put the duration, how long it's going to take. Okay? Everybody got it? Easy peasy? Okay, good. Then we need to do the forward pass. And we're going to calculate it, compute. And, you know, I don't like words because it's kind of gobbledygook. You know what I mean? I'd rather just see an example. So, fortunately, we have an example here. Then we can go back and say, oh yeah, that's what we're talking about. So here we go. Now, I want to clarify two things for you because I think it may have been Kenneth and I forgot your name over here. Ethan. So when I said, or maybe it was Jackson, when I said it takes 1 day, when can, no, it takes 2 days, when can it start? Or when it's going to finish? I think you said Wednesday, didn't you?
No, I said Thursday.
Thursday, but I said Wednesday night, right? And you said Thursday morning. Guess who's right? Guess who? Gabby, guess who's right? Take a guess. Both of us. Because both ways are fine. Either way is fine. Some people do it. Some say tomato, some say tomato, right? Either way is fine. But once you start using a method, you got to be consistent. So look at this. This is starting on day 0. Is there a day 0? No. But some people use it, day 0. I put day 1. Starts day 1 and take 10 days. Starts on Monday, on week 1, going to end Friday, week 2, right? 5 days, 10, you got it? So you could do that. You could put 1 and 10. Now look at this. When is this going to start? Day 10. If this finishes on Friday, Lauren, right? If this finishes on Friday at 4 o'clock, you think anybody's going to start working on it on Friday at 4 o'clock if it's only day shift? Where are people going to be? Happy hour, right? But looking at this, it looks like they could get started on day 10, right? That's cool. So you could do 0, 10, or you could do 1, 10, and what would this be, Ethan? 11. 11, right? It starts on Monday. You follow me? Either way is fine. Just be consistent. How you do it. So we're going to roll with this author because that's how he's doing it. We got to be able to go both ways, right? Back in the old days, people played offense and defense in football. You never find that today, do you? They specialize. So when you heard people going both ways, like in football, that meant they played offense and defense both. Okay, so check it out. Look it. We know that to do this, this has to finish, right? So the earliest this can start is day 10. You got it? How do I get this number? Anybody?
10 plus 5.
10 plus 5, that's right. 10 plus 25. Is this calculus?
No.
This is like 4th grade math, isn't it? I could go to a 4th grade class right now, they probably could get this. You think so? I'll have to try it someday. I was principal for a day at an elementary school one time. I went to every class from 2nd to 5th, and the best was 3rd grade. Because by the time they were in 4th grade, they were already lost. They already thought they knew it all. And the 2nd graders, they wouldn't mind, but the 3rd graders, they were the best. Okay, so all you do is just take these numbers and add them. You see that? Can you guys handle it? Everybody handle that okay? Yeah? Okay, look at this. This is the early finish for this one, right? Early finish, early finish. Which of these 3 do they put here? Kenneth, which one? You can see. 85. Why did they pick 85? Why couldn't they put 70?
You always want to plan conservatively.
No, that's not the answer. Why couldn't they put 70 here? This is really gonna determine if you've been following me. Kenny?
It wouldn't equal 100.
No? Why can't I put 70 here? Ethan?
H is dependent on E, so E has to be done before H can be started.
H is dependent upon E, G, E, F, and G, right?
Oh.
And so I have to go with the latest, earliest finished. Write that down. The latest, earliest finished. That sounds like an oxymoron. Right, Dylan? The latest, earliest finish. But that's true. Of these three earliest finishes right here, which one is the latest? What number? 85, so I put that there. You guys got it? Now, here's a good question. Do you think this is going to have any slack time? If this is 86, what's going to happen to this number here? What is it going to be? 101. Right now it's going to take 100 days for the project. We can't have this go to 86. But if this takes 71, do we have a problem? No. If this takes 51, do we have a problem? No. So guess what is true? What does this represent right here, SL? Slack? What's going on with these two? What do they have? Slack. Slack. They have free time, don't they? Because they could end up later, be done later, as long as it's not too late. As long as it's not later than what time? 80, 85. Very good. You guys tracking with me on this? Because your thought processes have to be same as mine to do this. That's why I'm taking the time to do a reality check to make sure that you're there. You got it? So this is the forward pass. So we got our earliest starts, we got our earliest finish, and we also have the total duration of the project, which is the earliest finish for the last one. So it's going to take us 100 days to do this project. Everybody with me? Great. Okay. Now, we're going to do our next iteration, which is going in reverse. And this tells you how to do it. It's better just to do it together. So let's check it out. What we're going to do is we're going to do some math. We're going to take the latest finish minus the duration and get the latest start. Write that down somewhere. Latest finish minus duration gives you the latest start. Okay? I'll write it down for me so I don't forget. Latest finish minus duration equals latest start. Okay, great. So let's go and check it out. All right. When you have the last one, what you do for the latest finish, it's the same as the earliest finish. That's a rule. For your very last task, the latest finish and the earliest finish are going to be the same number. That's a rule. Okay? Because if you made this number later, that's going to extend our project time. So they're the same. All right. So we already wrote down the latest start equals the latest finish minus the duration. 100 minus 15 is 85. Okay? Everybody got it? Now, here's another rule. You're going to carry the latest start to the next preceding activity where it becomes the latest finish. So look at this. Here's the latest start. It's 85, right? I have 3 tasks that are proceeding, don't I? I got G, I got E, and I got F. Right now, this is blank. This is blank. I know it says 85, but it's blank. What I should have done is I should have made more slides and we could do this in sections, but I got lazy. This number here, remember, these are blank. The rule says that for the preceding activity, all you do is take the latest start and you put it here as the latest finish for the predecessors. You see that? Put 85. Everybody got that? Make sure you have it. You got to have that. If you don't have it, you're dead in the water. You got it? Take the successive task, take that 85 and write it here. You with me? Once you have that, you're good to go. Because then you got to come up with this number here. Right now, this is still blank. This is not blank. So 85 minus 35 is 50. You with me? 85 minus 50 is 35. 85 minus 15 is 70. Got it? If you can do this, you can do the rest. Because now you take this, and now, good one. There's an unless. You see this? If there's a burst activity, remember a burst is 1 lane to 2 lanes, right? There is a burst. You see the burst? C goes to E and F. If there's a burst, you don't take this number. The big number, what number do you take? You take the small number. You take the small one. Because you want to be able to get it done earlier, not later. If you take this bigger number, it's going to make your project delayed. Okay? So look, if it's a burst, you take the smallest latest start. That also sounds like an oxymoron, doesn't it? The smallest one. And you put it there. So we got a burst. We're going to pick the smallest and we put it there. Everybody with me? What's 35 minus 25? 10. And look, we got another burst here, don't we? A is bursting to B and C. So we're going to take the smallest, latest start. 10, put it here. 10 minus 10, 0. 35 minus 25, 10. 30 minus 5, 25. Okay? I know this is somewhat confusing right now. You guys probably have not even done the Connect yet, have you? And it's fine. You got till Sunday. Once you get into Connect, I promise you, this is going to be clearer. And here's something else that I'm going to give you. This is a bonus, okay? There is a YouTube guy. His name is Sir Gantelot. Gantelot. Like Sir Lancelot, like the knights. This is an English guy. He's got an awesome YouTube channel where he talks about this kind of stuff. He will walk you through it in even more detail than me. He's going to give you another rendition. So you're getting one rendition today, an introduction. You're going to get another one when you go to your Connect, and you can get another one when you go to his YouTube channel. But I'm telling you, you got to get this. If you get this, you're going to be awesome, okay, for the next exam and for your project management career. You're going to be awesome, okay? So it looks like we're almost done, aren't we? But we're not. We got to calculate the slack time. The slack, and the slack is, we're going to do the total slack here and the free slack. But look, the total slack, you could do the difference between the latest start and early start, or you could do the difference between the latest finish and earliest finish. Either one, but they both work. Okay, so let's do that. So we said we're going to do latest start, early start, latest finish, early finish. Either one. So look at this. There's no slack here, right? And there's no slack here, is there? Because 35 minus 35 is 0, 85, 85 is 0. But, as I alluded to, we have slack here, and we have slack here. Okay? Because 50 minus 35 is 15, 85 minus 70 is 15. Likewise, 35. Now, what does this mean? This means that I could start this on day 35, and I'm going to be done on day 50, aren't I? And if I'm going to work on this one, I don't have to start till day 85. So on day 50, I can go on vacation, right? I can go on vacation for 35 days because I have free time. Or I could go on vacation earlier and start this later because I got 15 days slack, okay? So, I told you wrong. This is 70 days. So I can only take 15-day vacation. I can take those 15-day vacation at the end of that activity. I can do it at the beginning, or I can take 5 days in the beginning, 10 days at the end, or 10 days at the beginning, 5 at the end. I can take 15 days anywhere between day 35 and day 85. And likewise down here, I can take 15 days anytime between, I can take 35 days anytime between the start and finish. So here we have 15 days slack here. Do the math. We have 15 days slack here. We don't have any slack here. We don't have any slack there. We don't have any slack there. Okay? So, we now can calculate the critical path. The critical path is the path that's going to take the longest. And it's the path that has no slack. No slack. So look at this. No slack, no slack, no slack, no slack. This is the critical path. This path is going to take 100 days. Okay? And we know that because 10, 35, 85, 100. But look at this. This path here, we have slack of 15, 15, and 15. We have 45 days slack on these three tasks together. And on this one, we have 35 days. So we have three paths here, don't we? We have A, B, D, G, H. We have A, C, E, H. We have A, C, F, H. So these two paths here, this one and this one, have slack and this one does not. These are not critical, these are critical. You guys get this?
Quick question.
Yep.
Going back to the test software cell, you said that hypothetically you could take a 15-day vacation between days 35
Yes.
and 85?
Yes.
Okay.
Yep.
Oh, I see it.
Because I don't need to start this. I don't need to start this one. Whoops. I don't need to start this one until day 85. This, and this have to be done by 85. You got that? Because look. All right. There's a couple more things I want to show you. Let's talk about sensitivity. These two paths are not very sensitive, are they? They're only sensitive if you exceed the slack. If somebody takes 50 days too long to do this one, if they start on day 50, which is the latest start, and they finish on day 100, this can't start till 100, can it? And this is going to take 115 days because it's 15 plus 100. So then this becomes a new critical path. You see that? So if you exceed the amount of slack on the path, those non-sensitive paths can now become sensitive. Okay, what I want to show you now is something on the board. Okay, and I'm going to draw a picture of these two to make it clear for you. Okay. So the default dependency for task is finish to start. Okay? If I'm remodeling a house and I want to paint a wall, okay, I need to finish sanding the wall before I can paint it, right? If I start painting before the sanding's done, it's going to be a mess. So I finish sanding and then I start painting. Finish to start. You got it? So it looks like this. Okay, so here's task A, B, called finish to start. Got it? Okay. This is the least risky because you make sure that the predecessor is completely done. Now, another one you can do, this one you can call it start to start. So A is sanding the wall and B is go get some paint at the store. If you have two different people, can you do those at the same time? Yeah. Okay. You could wait until the sanding is done and then go and get the paint. You could do that, but that's going to put you behind because you can't start painting until the person comes back from the store. But if the paint is already there, as soon as you finish sanding, you're good to go. With me on this? So this is also a very, these are the two that I highly recommend. There's two variants on these. One is called a lag, and one is called a lead. Now, the lag looks like this. See that? I'm starting this, as soon as I finish, I started. But the lag, I said, no, you know, I'm going to be at a conference for 3 days. I can't start painting. Even though you finish sanding on Monday, I can't start painting until Friday. Because Tuesday, Wednesday, Thursday, I'm out of town. You follow me? It's still a finish to start, but there's a waiting time. That's called a lag. You got it? So when you do your Microsoft project, you put a number in there. A 3, it's finished to start FS 3. It's got to wait 3 days. You got it? Make sense? Okay. Now, the other thing you can do is instead of doing this, it can look like that. See that? You're not going to start them both at the same time. It's still, this is still FS, this is still SS. But it's like, well, you're painting, you're sanding, and I'll go to the store, but I can't go to the store until tomorrow. Or I'm sorry, I can't go to the store until a couple hours. So they're sanding the wall on a Monday. On this one, I could go to the store at 8 o'clock in the morning. You got it? You start sanding at 8, you used to go to the store at 8. This one, I start sanding at 8, I don't go to the store till noon. You with me? So it's a lead, but it's 0.5, half a day. You understand? So these leads and lags allow you to fine tune the relationships between these two. That's it. That's pretty cool, because that's what happens in the real world. All right, so that's what I have for you today.
No, I'm trying to press it.
I got
So-
86.